Locating real zeros of polynomials. That just means we're going to find all the solutions to polynomials on the real number system, but we may extend it to the imaginary number system also. So just be aware. First thing we're going to look at is the rational zeros theorem. Now, rational zero is actually any number that can be written as a fraction, which means you can actually find it with your graphing calculator. But this theorem is asking for the possible rational zeros. It's not the actual rational zeros, but the possible ones. And so the theorem that we're going to use is we're going to take the constant term, which is the term without the variable, find all of its factors, and then take the leading coefficient, which is the number at the beginning of the polynomial. Keep in mind we want to write the polynomials in decreasing order from the highest degree to the lowest. So we'll take the number that leads the polynomial, find all of its factors, and then write down all possible combinations of such ratios, and then include plus or minus with those. That's going to be the possible rational zeros. So we do have an example, and what we're going to do is just do what this theorem says. So we have the constant term, which is 9. I don't have to worry about the sign because I'm going to include it with the plus and minus over here. And then we have the leading coefficient, and we're just going to abbreviate it, lead coefficient, which is 4. So what we're going to do is, for the possible rational zeros, I'm going to call it PRZ for short. And let's just do equals. I'm going to list all the factors of 9. So all the numbers that divide into 9 are 1, 3, and 9. All the numbers that divide into 4 are 1, 2, and 4. So what I'm going to do is, on the rational zeros theorem, is put the 1, 3, 9 in my numerator, and 1, 2, 4 in my denominator. And then all we're going to do is do all possible combinations. So I'm going to take 1 divided by 1, which is 1. 1 divided by 2, which is 1 over 2. 1 over 4 is 1 over 4. So I'm done with the 1. And let's do the 3. 3 over 1 is 3. 3 over 2 is 3 halves. 3 over 4 is 3 fourths. 9 over 1 is 9. 9 over 2 is 9 halves, and 9 over 4 is 9 4. These are all possible rational zeros, if there are even any rational zeros. We'll talk about that later on. Now, if I had done this, and say for example I came up with like 3 over 6, which is a 1/2, since I already have the 1/2 listed, I don't need listed again. So all these should be unique factors, or possible rational zeros. So just keep that in mind. What we're actually going to do, we're going to learn how to find all the zeros. So this is a process that I use. Like I said, before the graphing calculator, I had to do this and then test each one of these until I found numbers that gave me a 0. And I'll show what I'm talking about in just a second. Now we don't have to do that. Now we can just graph and find a rational zero. We need at least one rational zero. You could use a rational zeros theorem if you want to, but it's not necessary anymore. And then we're going to break down the polynomial by using synthetic division. We're just going to keep on breaking it down to factors, and then we're going to solve those factors like we normally would. Set them equal to 0 and solve. The process you may not understand until we actually do it, but here we go. And whenever in doubt, use this process. You don't even have to factor anymore. So here we go. First thing I'm going to do, I'm going to graph this expression, x cubed minus x squared minus 7x plus 3. Now I made a mistake because my x squared is in a square, so make sure you type it in correctly. Most important thing. So I'm going to graph it. Now here's some things you need to keep in mind. This highest exponent is a 3. That's telling me I'm going to have 3 zeros total. Some may be repeated, but we're looking for 3 zeros. Now zeros are the same as x-intercepts. So if I were to cross or see where it's crossing the x-axis, it's crossing 3 times. So I can actually see them, but we can't use decimals unless they can be converted to fractions. So when we say find all zeros, we mean exact zeros. That's probably the word that needs to be included. Decimal approximations will not work here. So the first thing I'm going to do is look at my table and see where y is 0, and I see it at 3, but nowhere else does it show. So for one thing I know, based on the table, x equals 3, because that's where y equals 0, is a 0. See, when I say 0, I'm saying roots, I'm saying solutions to equations that equal 0, I'm saying x-intercepts. It all means the same thing. Now if I see a 2 more, these may be fractions. In other words, they could be nice decimals that could convert to fractions. One way to do that is to go to y equals, hit enter, and graph 0, or type in y equals 0 and graph it, which is the x-axis. And then do second trace. And this is the way I prefer to do it. You may know other ways, but this is the way I prefer to do it. And then I hit intersect, and then I just go down to that 0 and hit enter. And it's not a nice 0. I can't convert that to a fraction. So what that means is I gotta do the process, the long process, which isn't too bad. I gotta break it down. In other words, I'm going to use division to break it down. In other words, I'm going to use synthetic division. You can always use long division. I don't recommend it though. Since I have a 0, that goes on the outside of the synthetic division sign. Then my coefficients of the polynomial go inside, including the signs 1, -1, -7, and 3. So all we're doing is breaking it down. Bring down the 1, multiply 3 times 1 is 3, add -1 and 3 when you get 2, multiply 3 times 2, which is 6, add -7 and 6, which is -1, multiply 3 times -1, we get -3. When you add, you better get 0. If I didn't get 0, one of two things would have happened. Either x equals 3 wasn't a 0, or I made a mistake in here. Another way to check it right quickly, if I were to hit trace, 3, enter, it's the same thing as if I were to take 3 and substitute it into the original problem, original equation, and I would have got 0 as the answer. See, back in the day, I had to test every one of those for this particular problem up here to see if any of those were zeros before I could even do synthetic division. And I could have done synthetic division on all of those before I found one. So with a calculator, you can go immediately to the factor, to the 0. Now what this means is, since the expression, the polynomial began with x cubed, 1 is going to be our x squared, so it's going to be like 1x squared. I don't need the 1, but I put it in there anyway. Plus, and then we go x, and then we go a constant. This is a factor. And what we always do with factors, we set them equal to 0, and we're going to solve it. And the process we're going to use to solve is we're going to use a quadratic formula. So I need some space. Some bad things that may happen as I give myself some space. So now I have some space. So now I'm going to use the quadratic formula. I could do completing the square. I could do several things. But probably for most people, you want to use the quadratic formula. So I'm going to type it in or show you what it is. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And something else if you're wondering. That's your a, that's your b, and that's your c. A is 1, b is 2, and c is -1. See, I'm breaking this down, breaking all these down, if I need to where I have a quadratic, an x squared. So if I have it in x squared form, or a quadratic equation, then I can solve it with the quadratic formula. So when the problem is x cubed, I have to break it down one time before I get an x squared. When it's like an x to the fifth, I gotta break it down to x to the fourth, x to the third, before I finally get an x squared. So it's like 3 times then if it's x to the fifth. So that's like synthetic division 3 times. We won't do one that bad, but we may do one that has 4. Or x to the fourth in it. So here we go. We're just going to substitute the numbers in. B is 2. I'll write that up here, in case you're wondering. A is 1, B is 2, and C is -1. And so we're just going to substitute those in. 2 squared minus 4 times 1 times -1 all over 2 times 1. And we're just cleaning it up. So we get -2 on top, and we got 2 on the bottom. 2 squared is 4. -4 times 1 times -4 is a positive 4. 4 plus 4 is 8. It's positive 8. We have -2 plus or minus 8 is the same as 4 times 2. That 4 comes out as a 2, and that 2 stays. All over 2. I'm going to go over here to finish it. So now I'm going to write it like this. -2 over 2 plus or minus 2 square root of 2 over 2. I'm just separating each part of the numerator with its own denominator. These 2's cancel. -2 over 2 is a 1, or -1. These 2's cancel, leaving plus or minus square root of 2. So what that means is that we have x equals -1 minus square root of 2, and x equals -1 plus square root of 2. So we have our 3 answers. This is one of them. This is the second one. And x equals 3 was the third one. And we knew we were looking for 3 because of the x cubed. Something to also make mention of, just to verify these. I still got it graphed in here. If I hit second trace 5 and I move it over, hit enter 3 times, I get 0.414 blah blah blah. So remember that 0.414. So when I type in -1 plus square root of 2, I get my 0.414. See that? Which is no longer in there, but remember we got that. So it's just a way to verify that this is actually correct. We could do this the third zero the same way. But that's the process. Let's do another one. Now, the first thing we want to do is get all the terms on the same side. So I'm going to go ahead and add, we need a 0 on the other side, by the way. So we need to add 2x to the fourth. We need to subtract x. And we need to subtract 1. So that means we're going to end up with 0 on the right side. On the left side, we're going to get 3x to the fourth. These x's cancel out because they become 0, and then we have minus 3. So we're actually solving 3x to the fourth minus 3. Now, here's the thing. There's 2 ways of doing this, but to show you, to be consistent, I'm going to graph it. I'm going to do it this way first, and then come back and show you an easier way. Only if you know how to factor is there an easier way. So let's type it in. This is what I'm saying when I said that you don't even need to know how to factor anymore to do these problems. So I'm going to graph 3x to the fourth minus 3. Now see, it crosses two places. It looks like a 1 and negative 1, so I can use my table to verify. And there it goes, negative 1 and 1. So from the graph, I know that x equals 1 is a 0. And I know that x equals negative 1 is a 0. So what I'm going to do is I'm going to use synthetic division and break it down. Remember, this is 3x to the 4th. That 4 tells me I'm going to have 4 zeros. I've found 2 of them so far. So I'm going to start the 1, put the 1 on the outside. I'm going to put the 3 in there. Now I'm missing an x cubed, an x squared, and an x. So that means I have to use 0 or zeros for those. And then the negative 3. So watch that. 4, 3, 2, 1, constant. So bring down the 3, multiply 1 times 3, add. 1 times 3 is 3, add. 1 times 3 is 3, add. 1 times 3 is 3, add, and you get 0. Since this is x to the 4th, this leading coefficient is for x cubed. So we got 3x cubed plus 3x squared plus 3x plus 3. Now this is a factor, but the problem is it's a cube. We need it to be a quadratic. So what we're going to do is we're going to have to do synthetic division again. What I could have done, and I think I'm going to do it right now just to show you a way to save some paper. Instead of writing down this part that this is a factor, as long as I recognize that this is x cubed, I could have done this just to save some paper is all, and save some time. I can do synthetic division with this because I have to. I need to be a square. Right now it's a cube. Now I know that 1 is a 0 and I've already used that one, but I also know that negative 1 is a 0, so I have to use it this time. I've already used the 1 once. I can't use it again unless it was repeated, which it wasn't. So now I'm going to use negative 1 and break it down even further. So I'm going to bring down the 3. Multiply negative 1 times 3 is negative 3. Add. Negative 1 times 0 is 0. Add. Negative 1 times 3 is negative 3. And add. Now I don't need that one because that was from the previous one. Now once again, if you don't like that, what I did was I just did synthetic division on this using negative 1. That's where these 4 coefficients come from. Now this becomes 3x squared, and that's 0x, but I don't need that 0x plus 3. So that's a factor. Which means I have to solve that by setting it equal to 0. Now here's how we're going to solve this. You can use the quadratic formula because we have it as x squared now. I don't recommend that, but you can. I'm going to do something else. I'm going to subtract 3 from both sides. And then divide both sides by 3 to isolate x squared. And we get negative 1. To solve this, we're going to square root both sides, get rid of the exponent. Don't forget plus or minus. We get x equals plus or minus. Do you recall what the square root of negative 1 is? And if you don't, you will now. It's imaginary, it's I. And that makes sense. Here's the reason why it makes sense. When we graphed it, we saw 2 zeros. The other 2 zeros we didn't see. That's because they were imaginary. Imaginary. So here's the question. If the question were to find only the real zeros, this one says find all the exact zeros, but if the question were to find only the real zeros, then our only real zeros are 1 and negative 1. But when it says to find all of them, we gotta go on and find the other 2 because we know from x to the 4th that there are 4 zeros. 4 zeros. So there's 2, 1, 2, and here's the other 2, plus I, minus I. Now I'm just going to show you a different way, maybe a little bit faster. We have 3x to the fourth minus 3 equals 0. I'm going to go ahead and show you. I don't need that much room to do it. If you know how to factor, first thing you do is factor out that 3, and actually you don't even have to factor it out since it's an equation. You can just divide everything by 3 on both sides. You can do that with constants, with numbers. We get x to the fourth minus 1 equals 0. And then this will factor as the difference of two squares. X squared minus 1, x squared plus 1. And then you can factor that or not. It's totally up to you. You can just do this. X squared minus 1 equals 0. And x squared plus 1 equals 0. Then you can add 1 to both sides. And you get x squared equals 1. Square root both sides. Don't forget plus or minus. And you get x equals plus or minus 1. Then here you subtract 1. And you get x squared equals negative 1. Square root both sides. Don't forget plus or minus. You get x equals plus or minus I. So you could have done it that way too. If you know your algebra, by all means, this is a whole lot faster. Sometimes you have to do all this work. Use synthetic division more than once. Sometimes you don't. So if you can recognize some things, you can save yourself a little work. But here's kind of the rule. Whenever in doubt, use the long process. It may take some time, but it's not that bad. Now let's look at this example C. I'm going to graph it. That's my first reaction. Because I need to find a zero. A rational zero, at least one. So let's type in negative 2x to the third plus 11x squared plus x minus 30. We're going to graph it. Looks like I have 3, and I'm looking for 3 because of that exponent. Let's go to the table and see what we can find. I see 1. I see a 2. So I see from the graph x equals 2 and x equal 5 are zeros. And that's from the graph. And I have a third one over here. I think I can find that one. You're going to find out later on in a different video that one has to be able to be found on the graph. See these eyes up here? They travel in pairs. Square roots travel in pairs. So rational zeros don't have to travel in pairs. In fact, most times they don't. So that means that this third one, I should be able to find out my calculator. So what I'm going to do is I'm going to hit y equals. Go to y2, graph the X-Intercepts. I can use my intersect key. And number 5. And the only one I don't know is the one way over there, and I pass it up. There it is. Hit enter 3 times. Negative 1.5. If you don't know what that is, math enter. It is negative 3 halves. That's our third zero. And I'm done. Didn't have to do any work whatsoever. So just be aware. Sometimes you can find them all on your calculator. And that's the last one. Before I can do anything in the last one, I have to have it equal to 0, which means I need to subtract the 40 off. And you should be recognizing that this has 3 zeros. See them? Or see the reason why? Because of x cubed. So let's type in 2x to the third minus 12 x squared plus 26x minus 40. Graph it. Now I only see that 1, 0. Looks like it's at 4. If I don't want to use a table, I just want to hit trace 4, enter. I can do that also. Or use your table. You'll see at 4, we have a 0. Now that's the only one that it shows. And I know there's 3. That must mean the other 2 are imaginary. So let's do all the work. So from the graph, x equals 4 is a 0. So I'm going to use synthetic division now. 4 on the outside, 2, negative 12, 26, and negative 40. Go inside. This better be a 0 down here. If it's not, something's bad wrong. So let's bring down the 2. 4 times 2 is 8. Add, you get negative 4. Multiply 4 and 4, you get negative 16. Add, you get 10. Multiply 4 times 10, which is 40. When you add negative 40 and 40, you do get 0. So now we have 2x squared minus 4x plus 10. And we need to set that equal to 0 and solve. Now you can go ahead and do the quadratic formula right now if you want to. I personally am not, because I can see something I can do to make it a little bit easier. So what I'm going to do is, I see that these are all divisible by 2, so I'm going to divide out that 2. Just to make the numbers a little bit smaller. Now I'm going to use the quadratic formula. A is 1, B is negative 2, C is 5. So I have x equals, in case you're wondering on the quadratic formula, I recommend doing it this way. I'm throwing the numbers. This is B. This is B. This is A. This is C. And this is A. I'm running out of space again. Now, let's just clean it up. A negative and a negative makes that a positive 2. I always do the bottom next. That's a 2. Then just clean up inside the radical. That's called a discriminant, by the way. Negative 2 squared is 4. 4 times 1 times 5 is 20. We get 2 plus or minus 4 minus 20 is negative 16 over 2. Square root of negative 16. Oh, I don't need that. You know why I don't need that? Because 16 is a perfect square of 4, and the minus sign comes out as an I. So the square of negative 16 is 4i all over 2. And then I like to separate 2 over 2 plus or minus 4i over 2. 2 over 2 is 1. 4 over 2 is 2, which is 2i. So there's our other two zeros. 1 plus 2i, 1 minus 2i. Along with x equals 4. And that's the process that we go through. When never in doubt, use the process. But there may be easier ways. The last thing we're going to talk about is the intermediate value theorem, which is the theorem we need to talk about. What it says is that if you got two x values, and when you substitute those into the function, if there's a difference in the signs, then there has to be a 0. And here's what that means. Say you got this a and you got this b, and you find f of a and it turns to be something up there. And if you find alpha b, it turns out to be a number down there. Well, that must mean that from between there and there, the line, the curve, whatever it is going through the x-axis at 0. So it must be at least 1 0 that lies between a and b. Now, if we were to find, say for example, like a c, and it turns out that there's the alpha c, the y value, is a positive also. From there to there, it didn't go across the x-axis. No matter how it looks. It has to be a function, but you understand what I'm saying. It didn't go across it. So there's not. We don't know for sure if there's a 0 between those two. Nothing can guarantee that there is. So I'm going to show you how you can do this pretty quickly. Let's show you what it means. I'm going to graph x to the 4th because I like to graph. Makes my life a lot easier. Minus 10x squared minus 14x plus 21. Now between 2 and 3, this is 2, well that's 2 and that's 3. It is going through the x-axis there, so I know there is a 0, but I need to use this theorem to verify that there is a 0. So here's how we use that theorem. First thing we want to do is find alpha 2. And all that means is you're going to take the 2, substitute in there. What I'm going to do is hit trace to enter. You can also use the table, but sometimes you're dealing with fractions, so it's better to use the trace. And we get negative 15. And I'm going to type in or find alpha 3, which means I just hit 3, enter. We get 24. Notice, signs changed. That must mean that 0 is between those two. What that means is, by the intermediate value theorem, since the signs change, just make sure you use the correct wording. For f of 2 and f of 3, a 0 exists between 2 and 3. That's what's going on. Since a different sign, the 0 does exist. And if you think about it, if you find f of 2, you get a negative number, f of 3, you get a positive number. You know that 0 is between those two. If you want a number line, if you were to do a number line, 0 is between those two. Simple as that. And that means there is a 0 between 2 and 3. The x values. That's all it is.